is this? Take a look. NASA scientists say it's a comet. That's what they say. They've named it the 3-1 Atlas interstellar object, which was discovered last month.
On the observation screen, a streak of light shot across space at a speed that made the entire control room fall silent for a few seconds, like the moment when humans accidentally encounter something that does not belong to this world. Scientists call it 3I Atlas, a comet from outside the solar system, but right from the moment it appeared, it planted more questions than answers. Its unusual orbit, strange glow, and unbelievable speed make people wonder, is this really just a drifting block of ice and rock, or is it the trace of something beyond the imagination of mankind? After Oumuamua and Borisov, 3I Atlas is considered the third interstellar visitor to ever pass by us, but unlike the two names before it, its appearance has sparked a series of wild hypotheses, from alien technology to secrets of the universe that have never been revealed. And the biggest question is, what is really happening with 3I Atlas? Oumuamua in 2017, an object with no typical cometary coma, yet suddenly accelerating in a strange way, making many even believe it was an artificial device from an alien civilization. Then in 2019 came Borisov, a comet much more normal, with a clear structure, a faint cloud of dust and gas surrounding its nucleus, exactly like the comets we have seen within the solar system. And then in 2025, 3I Atlas appeared, like a mysterious character stepping onto the stage, making all previous comparisons suddenly irrelevant. Unlike its famous predecessors, 3I Atlas did not resemble either of them completely, because from the very beginning it presented a whole series of characteristics that made the scientific community both fascinated and unsettled. First, it was discovered on July 1, 2025, by the Atlas Telescope in Chile, a shocking strike when few expected this object to truly come from beyond the solar system. This visitor moves on a hyperbolic orbit, meaning it will never return. It will pass by and vanish, impossible to come back. What made many drop their jaws even more was its velocity, about 58 kilometers per second, equivalent to approximately 210,000 kilometers per hour, many times faster than either Oumuamua or Borisov. That made 3I Atlas the fastest moving object ever recorded from outside the solar system. Furthermore, its size also astonished people. Early estimates showed it could be about 10 to 25 kilometers wide, much larger compared to Oumuamua, cigar-shaped only a few hundred meters long, or Borisov, with a diameter of just a few kilometers. To call 3I Atlas a timeless enigma would not be wrong, because its age could reach 7 to 11 billion years, double or even 1.5 times the age of our solar system. Research on its age and velocity suggests it might be a remnant from ancient stellar systems, adding to its layers of mystery. Not stopping there, sharp images from the Hubble telescope showed that 3I/ATLAS has a dusty coma, confirming it truly acts like a comet, releasing gas and dust when under the sunlight. What is fascinating is that even from a great distance, about 3.5 astronomical units, signals of OH emission, a marker of water vaporizing, were still detected, showing that its outgassing activity was much stronger than many typical comets at the same distance. In short, when placing 3I Atlas in the sequence of past interstellar visitors, Oumuamua and Borisov, we immediately recognize it stands outside all the old rules, not the rigid, mysterious object like Oumuamua, not the ordinary comet with a clear structure like Borisov, but something bigger, faster, older, and stranger. That is why it becomes so compelling. Not just an object among the stars, but seemingly a secret waiting for humanity to uncover. People often imagine the universe as a calm ocean where everything gently drifts among the stars. But then 3I Atlas appeared like a sword slicing across that vast stage, startling even the most dreamy minds. On July 1, 2025, when the Atlas telescopes discovered this strange object, what shocked everyone first was not its glow, but its speed. About 130,000 miles per hour, equivalent to more than 58 kilometers per second, placed 3I/ATLAS among the fastest objects ever influenced by an interstellar trajectory. That very number stunned astronomers, because compared with Oumuamua, the first interstellar visitor ever recorded, 3I Atlas was not just a little faster, but almost twice as fast. During its flyby of the solar system in 2017, Oumuamua reached a maximum velocity of about 87 kilometers per second when it was closest to the Sun. That speed alone was already enough to make people shiver, but 3I Atlas went beyond, underlining a chilling truth. The universe still hides mysteries humanity has not even begun to imagine. So try to picture the scene: a bright dot, fast as a bullet, shooting through the black void as if it were fleeing from some mysterious force out there. That speed forces the mind to ask questions. Is it merely a fragment of frozen gas breaking apart, or has something implanted an unnatural push into it? Could there be a hidden source of energy somewhere beyond our system, propelling it forward like that? In particular, scientists confirmed there is no planet in the solar system strong enough to accelerate it to such a level. It is not the product of a gravitational slingshot from giant planets, as is the case with some other asteroids. The orbit of 3I Atlas is hyperbolic, meaning it will not return, it is not bound to the Sun, and it will vanish forever after it passes by. Its extraordinary speed is not only a cold number, but a silent story about the past, the origin, and perhaps even about an inexplicable force. Looking at the data, people see not just an interstellar object, but also sense the rise of a hidden mystery. That very speed stuns us with a chilling feeling. Just because humanity has never witnessed it before does not mean the universe does not harbor velocities and forces beyond all our ordinary concepts. And thus, the great question naturally arises: could this speed be not simply the result of cosmic motion, but the trace of an unnatural propulsion from a force we do not yet understand? Is 3I Atlas fleeing from something or heading toward something? The cruelty of that speed, far beyond imagination, is itself an invitation, awakening our deepest curiosity about the journey of 3I Atlas. When we picture an interstellar object like 3I Atlas, many might think of it as nothing more than a cosmic traveler, appearing in a flash and vanishing just as quickly. But what if we dare to propose that its journey is not just a fleeting visit, but an ancient message sent from billions of years ago, from the deepest parts of the Milky Way? Astronomers have revealed that, according to galactic dynamics and composition models, 3I Atlas originates from the thick disk, the oldest component of the Milky Way, home to the oldest stars, poor in metals compared to our Sun. Once again, the data makes people pause in awe. According to the Oumuamua-Oxford model developed at Oxford, there is a high probability that 3I Atlas is at least 7.6 billion years old, and it could be much older, nearly twice the age of the solar system. Another study, going deeper into kinematic analysis and velocity dispersion by stellar age, produced a spine-chilling figure, 3 to 11 billion years old. And an even more independent approach, based on robust statistical modeling, showed an average age of 9.6 billion years, with a confidence range of 7.8 to 10.3 billion years. Imagine it: a frozen rock drifting slowly across billions of years in the darkness of space, carrying memories of the era when the Milky Way itself was only just forming. It is poetic beyond measure. If 3I over ATLAS was indeed born in the thick disk, that means it could be a relic from the dawn of the galaxy, containing the most primordial material, rich in water ice, poor in heavy metals, elements that can easily be envisioned as simple frozen water. Picture the scene: not just a ball of ice racing across the sky, but a trail of melting ice dust, like an ancient message traveling billions of kilometers to reach us here and now. That strangeness does more than send shivers. It sparks the feeling that in every molecule on the surface of 3I Atlas might lie an inscription of the galaxy's history. Even more striking is this: if it truly is that ancient, then 3I Atlas is older than our entire solar system, a living block of data, moving through space and time, surpassing all astronomical histories we have ever known. When we turn our telescopes to follow it, it is not just to observe a passing comet, it is to touch a fragment of history, a piece of the past we have never seen before. The gravity of this discovery lies in the fact that if 3I Atlas is indeed a heritage of the Milky Way's ancient times, then all theories about planet formation, about primordial cosmic material, and about galactic evolution must be reconsidered. Data on its age and origin is no longer just something on paper. It is alive before our very eyes through telescopes, models, and concrete evidence. The journey of 3I Atlas is not simply a strange occurrence, but the universe's invitation: learn from the past. And as the story gradually unfolds, we see not just another comet, but we feel the heartbeat of time, a connection to a history older than the very world we live in. What makes this revelation even more captivating is the sensation of having just discovered a cosmic secret long hidden, a secret lying far beyond ordinary speculation. In the minds of many, an interstellar comet is like a cold stone, appearing briefly and then vanishing, leaving nothing behind but a faint streak of light. Yet 3I Atlas has overturned all those assumptions. When it first appeared, it drew attention not because of its size, but because of its unusual brightness, leading people to imagine it as a massive rock of absurd proportions. Many early assessments suggested that to shine so strongly, if it were purely natural, its diameter would have to be tens of kilometers, far larger than any comet previously known. And yet, the Hubble Space Telescope revealed a truth that stunned many. 3I Atlas has a clear coma and a dust tail, meaning it truly behaves like a comet, not a giant lifeless rock. An image taken on July 21, 2025, showed a teardrop-shaped cloud of dust erupting from its icy core, along with a faint tail behind, evoking a sense of vitality amid the frozen void. Not only that, astronomers recalculated the size of its nucleus based on these images. The results were astonishing. Its core diameter is most likely under 5.6 kilometers and could even be as small as 320 meters. This means 3I Atlas is not the giant once imagined, but merely a small comet, and yet it burns brilliantly, active and luminous against the cosmic horizon. This paradox itself is the twist that makes the story gripping: a small object with an extraordinary power to shine, making it impossible to look away. It raises a bigger question: why would such a small comet be so unusually active compared to examples we know? The nucleus is not large, yet the dust it releases is thick and abundant, showing intense outgassing, behavior rarely seen in comets of similar size within the solar system. According to Hubble's analyses, 3I Atlas was already releasing dust from as far as 3.8 astronomical units away from the Sun, well before reaching its closest approach. This is behavior only found in comets that act differently, since typically such activity only happens once they are deep within the system. Moreover, the teardrop shape, with its dust halo clinging to the side facing the Sun rather than just trailing behind, further emphasizes the strangeness of 3I Atlas's activity. The combination of small size and extreme activity makes 3I Atlas a paradoxical figure that stirs endless curiosity. If other comets are ordinary light bulbs, then 3I Atlas is a floodlight blazing, constantly spewing dust and gas despite its surprisingly tiny body. If other comets are ordinary light bulbs, then 3I/ATLAS is a floodlight blazing, constantly spewing dust and gas despite its surprisingly tiny body. And this leads to a question that cannot be ignored: why is this comet so intensely active? Is its ice and material composition unique? Or is it interacting with interstellar gases in a way we have never seen before? Are there cosmic forces at work secretly driving it to behave so violently? On a distant dawn, October 29, 2025, the universe will stage a scene full of enigmas that will leave scientists and anyone curious about interstellar mysteries holding their breath. On that very day, 3I Atlas, the wanderer among the stars, will come closest to the Sun at a distance of 1.36 astronomical units, about 203 million kilometers, lying between the orbits of Earth and Mars, close enough to feel the heat of the solar rays, yet still keeping a safe distance from our planet. This moment is seen as the golden hour of a secret dialogue between the cosmos and high-tech telescopes. It is the opportunity for the James Webb Space Telescope, JWST, to eavesdrop on the chemical language whispered by 3I Atlas through the reflected light from its icy and dusty shell. Measurements of water, carbon monoxide, carbon dioxide, and methane will become crucial signals, like the first letters of a cosmic code. Because JWST, with its ultra-sensitive infrared vision, can trace the vapor of water rising as that ancient surface draws nearer to its parent star. In fact, scientists have placed great expectations on JWST during this period because it will not only capture light, but also decode the delicate chemical composition within the coma, the hazy cloud surrounding the comet's core, helping them sniff out the mystery. So far, only water in the form of ice and vapor has been detected from afar, but molecules such as CO, CO2, and methane remain key targets, for they may reveal the object's origin, whether 3I Atlas was born in an ice-rich, metal-poor environment like the thick disk or somewhere else entirely. And if unusual or excessive ratios are detected, that could be the key to opening the door to its birthplace, or, more daringly, lead us toward hints of primitive life beyond the solar system. The seriousness of this moment lies in this: if JWST records abnormal components, it would not be just a laboratory discovery, but something that could force us to rethink how matter was formed around primordial stars, or even about the habitats of life billions of years ago. This is not merely an ordinary observation, but a uniquely rare chance to capture traces of the early universe in their truest form. In the days after perihelion, as 3I Atlas gradually sinks into the darkness opposite Earth, JWST and ground-based instruments will continue monitoring, like cosmic detectives not missing a single second of its signals. And if that reflected light remains cold or shows spectral anomalies, it will trigger new hypotheses, from metal deficiencies to irregular weathering to the possibility that it still carries primitive organic molecules, the fundamental ingredients of life. If within that icy shell lies a concentration of CO2 or methane far above expectations, then that may be the key to unlocking the birthplace of 3I Atlas, or perhaps the very first clue leading us to life beyond the solar system. On the stage of the cosmos, Oumuamua once played the lead role as a figure of mystery. In 2017, it swept through the solar system with a strange shape, without a coma or a tail, a peculiar stone, cold and striking. 3I Atlas, on the other hand, is the opposite, an unmistakable comet, blazing with a surrounding halo of dust and gas, shining more brilliantly with every passing day. Placed side by side, the two are like polar opposites, one cloaked in silent mystery, the other in dazzling, restless activity. But when you look closely, a bigger question emerges. If 3I Atlas is just a comet, then Oumuamua is truly the anomaly. Yet if both are strange in their own ways, one a riddle in silence, the other a riddle in radiant brilliance, then perhaps what we are witnessing is a larger pattern, pointing to cosmic rules not yet understood. One of the boldest ideas to arise in this context comes from astronomer Avi Loeb and his colleagues. In a paper, they proposed using NASA's Juno spacecraft, currently orbiting Jupiter, to perform a flyby of 3I Atlas. They even gave specific numbers. With only about 110 kilograms of fuel burned, less than 6% of Juno's reserves, the spacecraft could get within roughly 25 million kilometers of 3I Atlas, an unprecedented level of proximity. If this plan succeeds, it would mark the first time humanity has ever sent a spacecraft to approach an interstellar object, not just through distant telescopes, but with the literal touch of technology. If 3I Atlas truly is an ancient comet, as most observations suggest, then such an encounter would allow us to peer deep into the past of the universe, gathering material older than the solar system itself. Yet this hypothesis is not only about engineering, it raises a much larger story. If 3I over ATLAS truly is an ancient comet, as most observations suggest, then such an encounter would allow us to peer deep into the past of the universe, gathering material older than the solar system itself. But if the object bears any trace of something non-natural, like the remnant of technology, then the consequences could go far beyond anything we imagine about our place in the cosmos. The idea even received political support. U.S. Representative Anna Paulina Luna sent a request to NASA urging consideration of extending Juno's mission to pursue this monumental goal. Still, skepticism has been voiced. Juno is running low on fuel, its engines no longer work at peak capacity, and its current priority remains the study of Jupiter. But the proposal itself creates drama, a rare chance, a possible curse, or an invitation into something that has never happened before. In the end, the story between Oumuamua and 3I Atlas becomes a compelling juxtaposition, one a silent riddle, the other an active one, fleeting appearances that remind us there are forces beyond our comprehension. Is the anomaly already woven into the fabric of the universe, simply waiting for us to uncover it with the right tools? If humanity dares to steer Juno through the cosmic darkness to reach 3I Atlas, we would not merely be chasing a comet. We would be chasing the very future of interstellar exploration, and perhaps the future of humanity itself. 3I Atlas is not merely a strange object passing through the solar system. It is a gateway into the distant past of the Milky Way, carrying within it traces of epochs older than our very solar system. Every piece of data, its speed, its age, its structure, its chemical makeup, is like a fragment of a puzzle, forcing us to re-examine everything we thought we knew about the universe. At the same time, the arrival of 3I Atlas serves as a reminder that humanity still lives in a vast cosmic ocean full of mysteries, where other intelligences and messages may exist far beyond our current understanding. When compared to Oumuamua and Borisov, we can see even more clearly that the universe does not follow fixed patterns. Perhaps 3I Atlas is just a unique comet, but it could also be a vital piece in a much larger picture about the evolution of galaxies or even about life beyond Earth. And the great question before us all is this: do you believe 3I/ATLAS is only a comet? Only a few months remain, and on October 29th, 2025, when the James Webb Space Telescope turns its gaze toward 3I Atlas, humanity will have the chance to decode the chemical signals it brings. That will be a historic moment, and we will be right here with you to follow it. Share your thoughts in the comments, and don't forget to subscribe to MindGap so that together we can witness the moment JWST illuminates this interstellar visitor and continue uncovering the other secrets of the universe with us.